Hello everybody, this is Mr. McAllen, and we're going to work on some of these problems on page 2 of the open-ended review. So getting right into it, the first question, it says to list all of the possible rational roots, and what we need to do is find our P over Q ratio and find all the factors of that. And we're going to use for P it's 27, it's the last value, and for Q it's 1. So when we list all the possible factors, we have plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 27. And on the bottom we would have plus or minus 1, which gives us the possible factors to check as being plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 27. When you go and try to do this, to find in the next part factoring completely by using synthetic division, you need to just be lucky and find the right value. So I'm going to be lucky on this first one. I'm going to put plus 1 in for my first root to check, and I'm going to check it against about 1, negative 10, 6, 30, and negative 27. And when I look through that, I'm going to just bring the 1 down. And you can follow along. I'm sure you've done enough of these problems to know what you have to do. And as you can see here, I got lucky with the first number I picked, 1 for the root. So x equals 1 as a root because I got 0 for a remainder. And now I'm going to just try synthetic division again. Normally I would go through the roots and I would try negative 1, then positive and negative 3, and then positive and negative 9, and so on. I'm going to just take a guess right now and try 9 and see how that works. And when I try 9, I bring the 1 down, and that makes 9, and that's 0. 9 times 0 is 0, so I put 0 there. Negative 3. So when I multiply 9 by negative 3, I get negative 27, and there you have it. I have a 0 remainder. So as a result, I know that I have 1 and I have 9 as roots. So now I've got to figure out what to do with these last few coefficients. This basically means that this is equal to x squared, and minus 3 equals, well, is my remaining polynomial, and that is, my other factors are x minus 1 and x minus 9. So I know from this my other two roots are going to be x is equal to plus or minus root 3, and when I set that equal to 0 and solve. So when I'm going to plot this, I've just got to now use the zeros. So I'm going to put a 0 at 1, I'm going to put another 0 at 9, I'm going to put a 0 at root 3, which is just under, oops, root 3 is really close to 2, so this is going to be kind of tough to see. And then negative root 3 is about here. So if you look here, let me just zoom in a bit. If we look really close, our function, because it's a positive x to the fourth, our end behavior will look like this. It will look like a parabola on the ends, and it's going to come through. It's going to go up and then down and then through that root and exit. So that would be a fair representation of what our plot would look like. On the next problem, number 6, it wants us to show all the asymptotes those that do not correspond to an axis as dashed lines. List the x and y intercepts. So, okay, so when we want to find our, the first thing I want to find are vertical asymptotes. That's by setting the denominator equal to 0, so we need to factor that. So we have x minus 4, x plus 1. So our vertical asymptotes will be at whatever makes that denominator 0, which is at x equals 4 and x equals -1. On the next line, it asks for horizontal asymptotes. Now, for horizontal asymptotes, we identify the degree of the rational function, and because the degree in the numerator is degree 1 and the degree in the denominator is degree 2, then we know the overall degree is -1. You just take the numerator degree divided by the denominator degree. The overall degree is equal to -1, and that means our horizontal asymptote will be found at y equals 0. Anytime the degree is -1 or lower, the horizontal asymptote is at y equals 0. And the equations for a slanted asymptote, if any, you just put none, because once you have a horizontal asymptote, you will not have a slanted asymptote and the sketch. Well, in order to sketch, you should also list your x and y intercepts. So the x-intercept is the same as a 0, and that would be at when x minus 1, the numerator, equals 0. So that answer to that would be at x equals 1, you have a 0. So I'm going to plot that. And a y-intercept is when you plug in the quantity x equals 0. That'll tell you where you're crossing the y-axis. So in this case, that's going to be at 1/4, which is almost impossible to plot on this graph. So now I have those two things plotted. I'm going to plot my my horizontal asymptote is going to be at y equals 0. My vertical asymptote is going to be at 4. And at -1. And through the use of test points, I would see that the function is got this type of behavior on this side, and I would need to test a point on the left and on the right of these vertical asymptotes. So let me just change the ink. Well, I'm back. I did a few calculations here. I plugged in, I have like a table here to plug in test point values. And when you plug in -4 into this equation, you have -4 plugged in for x, and you plug it in for the denominator, and what you end up finding is that for -4, the value that comes back is -5/24. That's negative and very close to 0, so I have that plotted right there where I put that point. It's just a sketch. And then when I plug in I'll plug in 5. So I'll plug into the same equation. I have 5 minus 1 over the quadratic in the bottom. And you end up getting 4 over 25 minus 15 minus 4, and that ends up being 4 over 6, which is positive. So that tells me that when I'm at 5, I'm at a positive value. So from this, I have enough knowledge to understand that the graph is going to be moving in that direction on one end and in this direction on the other. And that would conclude what my plot would look like as a sketch. I'm going to just clean this up and I'm going to work on the next problem. So let me pause for a second. And on the last problem on this page, I have a quadratic equation to solve. And I'm going to take 5x squared move the 40x over to the other side, set that equal to 0, and whenever you have a quadratic, if it's two terms, you should try factoring. So in this case, I'm going to factor 5x out, and I have x minus 8 as the binomial left over. I set that equal to 0, and I have two solutions. I have 5x equals 0, and then I have x equals 8. So those are my two solutions to that quadratic. If you were graphing this on a graphing calculator, you would see that in this case, for this function, you would have a 0 at x equals 0, and at 8 you would have another 0. And you would have a parabola passing through the two zeros. Let me make sure that's passing through. So on the next equation we solve, it is a trinomial. Now normally we would have to do synthetic division, but sometimes you can get away with trying to do factor by grouping. So that's what I'm going to try here first before I get into doing anything with synthetic division. So if I just try to group the terms, what you see is I didn't group the negative, so I changed the sign of the second term. So I'm going to factor out an x squared. I have x minus 7. And I'm going to factor out an 8. So I've got, again, x minus 7. And now I feel good about my factors. I have x squared minus 8 and x minus 7. So all set equal to 0. And from the first one, I know that when I set x squared minus 8 equal to 0, I get two roots. X squared equals 8, and x will equal plus or minus root 8, which is otherwise known as, or simplified to be, plus or minus 2 root 2. And my other 0 is simple. It's just going to be x equals 7. So those would be my two solutions, or three solutions for this problem. I have x equals plus or minus 2 root 2 and 7. I'm gonna. Oh, I think I've hit 12 minutes, so I think I'm gonna stop recording right now and clean up the tablet, and then start out with the last video.